Okay, so here's a video on how to think about the link between the graph of a quadratic and how to get its equation. So there's a lot going on the screen. We're going to concentrate on the left. So I've got y equals to x squared plus x minus 6. And if I was thinking of graphing this, then of course you could sketch the little axes here. And the y-intercept, when x equals 0, y equals negative 6. So that would definitely appear there, wouldn't it? Okay, and now find the zeros. So we're solving x squared plus x minus 6 equals to 0. Okay, and when we solve that, you probably don't need to split the middle term because it's easier numbers. It has to be 3 times 2, I think, to give negative 6. One's a negative, one's a positive, and you'll find it's positive 3, negative 2. So here x equals to 2, x equals to negative 3. So there's the two zeros, okay? 2 here and negative 3. And we've kind of got our sketch then, and I'm not going to go and find a vertex. Remember, we would be able to find the vertex by finding halfway between the zeros and having this nice line of symmetry going down it here, okay? But I'm going to leave it like that. Now, if I go to Desmos just to check this, okay, here's in blue, x squared plus x minus 6, okay? And here are the zeros. They are negative 3, 0, that's the full coordinates, and 2, 0, and the intercept is 0, negative 6. So we sketched it correctly, didn't we? Absolutely fine. So it looks like you've got to think, well, how do we move backwards? If I had this picture, then how could I actually get the equation of the graph? So let's just think about the process. So if I start with this picture now that I've just drawn out, if you think about it, our zeros were x equals to negative 3 and x equals to 2. That's where our zeros. But then, so that matches kind of to this line. But if you think about it, if I have two zeros, then the line before must have come from x plus 3 equals 0 and x minus 2 equals 0, okay? So where did that come from? That came from x plus 3 times by x minus 2 equals 0. And isn't that just the equation? X plus 3 times by x minus 2. So can you see that given two zeros, as in where the graph crosses the x-axis, we can just work backwards one step, backwards another step, and we can get back to the actual equation we had to start with. So that's pretty good, isn't it? Pretty funky. So if we do another one now, let me just skip those, come back to those. Let's just do another one for practice. If I had this guy here, okay, 5 here and 1 here and 5 there, if we thought about what's the equation of this graph, well, let's try it. X equals to 1 and x equals to 5, okay, so that form must have been x minus 1 equals 0 and x minus 5 equals 0, so that must have been x minus 1 into x minus 5 equals to 0. So that must have been y equals x minus 1 into x minus 5. Now if we expand that and tidy up, you'll get x squared minus 6x plus 5. And now we're going to check this last question here, okay? I'm going to check it, because if this is y equals x squared minus 6x plus 5, then when x equals to 0, y should be equals to this number here, the y-intercept. So let's just do that. Y equals 0 squared minus 6 times 0 plus 5. Yeah, that seems to work. So it looks like it's quite easy to get the equation that we want, but we have to be careful, okay? So this is where I'm going to go to Desmos again. So have a little look at this graph of Desmos. And if we go back to our very first picture here, this is x squared plus x minus 6. It factorized nicely like this, okay? And we got this lovely graph over here, which is correct. But the problem is that there are other graphs that will also have the zeros at negative 3 and 2. And I'll give you a picture here. Okay, can you see the green graph now? So the green graph seems to be a lot steeper, but it still goes through the same zeros, but it has a different y-intercept. Okay, so same zeros, but a different y-intercept. And if you have a little look at those two equations, one's just doubled the other one. All right, so we have to be careful about finding the equation of the graph. If we just look at the zeros, then we're not going to get the exact graph. Let me just show you one more trick here. If I turn both of these off here, and I plot this graph here, and I have a look at the zeros here again, look, these are the same zeros as before. Now this is an upside down graph, different to the one we started with. And as I change the value of a, can you see we're getting different shape parabola? Okay, sad face, concave down, because look, the a value is negative here. It's negative x squared. So it all depends upon how much you're scaling your graph. Okay, so we have to be very, very careful when we try and work out the equation of a graph. And so here's the method. Okay, so for each of these questions, we're going to do it quite carefully. All right, so for this first question here, I'm going to do the first basic step, which is to say x equals to 2 or x equals to 3. So therefore that must come from x minus 2, x minus 3, okay, because that's equals 0 equals 0. So that must have come from x minus 2 times by x minus 3. That will be y equals, but now we're just going to put one more little extra in, y equals some scaled up version of x minus 2 into x minus 3, okay? And then we're going to find out what that a value is, all right? You can expand the brackets if you like. When I expand the brackets, leave the a where it is and just multiply out the brackets here. You should get x squared minus 5x plus 6, okay? And so I've got an equation y equals a times by x squared minus 5x plus 6, okay? Now in order to find the a here, we've just got to substitute a single xy pair of values that's on the graph that we haven't used yet. So we've used the 2, we've used the 3 here, we haven't used the 6 here. So this is when x equals 0, y equals to 6. Okay, so let's substitute that in. So 6 here, 6 equals a into 0 squared minus 5 times 0 plus 6. 6 equals to 6a, therefore a equals 1. Okay, so in fact our equation here is y equals 1 into x squared minus 5x plus 6. And if it's just times by 1, we don't actually need the 1 there, do we? So y equals to x squared plus 5x plus 6, small eraser on. Okay, now the next question, we'll just do this one and then I will leave you to it. Let me just copy this. Copy. Let me add an extra page in after. Let me paste it in. Okay, so let's have a look at this one. Now look, this is an upside down, so we know it's going to be y equals negative x squared and some x's and some numbers, all right? But is it negative 2x squared? Is it negative 5x squared? What is it? Okay, so let's go through the steps. So x equals to negative 2 or x equals to 5. Those are the two zeros. Where did that come from? X plus 2 equals 0 or x minus 5 equals 0. They came from the factors of the quadratic, and therefore we've got y equals x plus 2 into x minus 5 with an a here. Okay, if you want the expanded form, you'll find it's a into x squared minus 3x minus 10. Okay, but now we need to find what that a is. Okay, so let's try and find it. So just substitute a pair of xy values into your equation. Now, which xy values have we not used? Well, we've not used this point here, have we? So this is when x equals 0, y equals to 20. Alright, so let's use that. And I think I'm going to use it in, actually, I'm going to use it in this form that's not been expanded, okay? So this is exactly the same as this, just one's expanded, okay? One's factorised, one's expanded. But I'm going to use the first format. So the y value, which is 20, that has to satisfy a into the x value, that's 0 plus 2, into 0 minus 5. So 20 has to satisfy a times 5. Well, what's the answer for these guys? This is just 2, and this is just negative 5. 2 times negative 5 is negative 10. So that's a times by negative 10. So I think a is equal to negative 2. Alright, so I have now the equation here. Y equals to negative 2, and in the factored form it's x plus 2, x minus 5, and I like it in the factored form because it gives you a lot of information about the graph. But if you did want to multiply it out, it would be negative 2 into x squared minus 3x minus 10, and then if you expand the brackets, it's minus 2x squared plus 6x plus 20. Okay, so you've got two different versions there. There's the expanded form of the quadratic, and here's the factored form of the quadratic. Now, I'm just going to go into Desmos just to confirm that. Let's just get rid of all of these other windows. And we'll just type that in and see what we get, okay? So this is y equals negative 2. I'm going to do the factored form first. X plus 2, close bracket, into x minus 5, I think. Yep. Okay, so let's have a look here. The zeros are, I'll make that a little bit bigger now. Okay, the zeros are here. 5, 0, negative 2, and 0, 20. Perfect, we've done it. Alright, and let's have a look at the, let's take that off again. Let's look at the expanded version to see if we expand it correctly. Y equals to negative 2x squared, and that is plus 6x plus 20. Okay, and that is here, here, and here. Okay, so it looks like we have got the answer correct. So that's how to actually go from a picture of a quadratic graph, given the zeros and one other point on it. Okay, so now if we go back to the iPad, we can just go to the summary. Now the summary is this little slide here. Okay, so this version is the general form of your quadratic. Okay, we know that. All right. But if we put it into factored form like this, and remember we need that little a there as kind of like a scaling up and making it stretch the graph, then all we have to do is find the zeros, n and m. We start by saying x equals to n and x equals to m, and it doesn't matter if they're positive or negative, and the line before that will be x minus m equals 0, x minus n equals to 0. The line above that will be x minus n times by x minus m, and that will be y equals, but then we have to put in that little scale factor a times by. Okay, so that's the technique to use. Given two zeros that you know and another point on the graph, you can substitute the two zeros directly into n and m. Then to find the a, you'll have to substitute an xy pair of values. Alright, give that a go.